our lessons tonight. We do some discussion on the paper 1, chapter 5. Okay, page 74. Okay, have you tried these questions? Okay, table shows the proton number. Okay, proton number for 5 elements. That's J, K, L, M, and N. Okay, there are 5 elements given here. So you see the proton number given. Okay, 2, 6, 11, 12, and 17. Okay, so which of the following pairs of elements read to form covalent bond? Okay, covalent bond. Yeah, page 74. So class, let's see. Covalent bond, it must be non-metal with non-metal. Okay, so we can see their electron arrangement to determine whether they are metal or non-metal. Okay, so J proton number is 2, so electron arrangement also 2. So meaning that what is J class? 2 valence electrons, so it's triplet electron arrangement, right? So meaning that J actually is helium, so group 18. So group 18 never react. Okay, never react. So you can see, go to see if there is J, meaning that it's out already from our out of the answers got already. Okay, K is 2, 6, so it's 2, 4. Possible, group 14. L is 2, 8, 1. So group 1, so L also out because one valence electron is group 1. So it's a metal. So L is also out. So here L, so it's out already. Now left C and D. Okay, now M 12, so it's 2, 8, 2. Okay, 2, 8, 2, so group 2, so metal also. So M also not possible, so not possible. So this one is 2, 8, 7, so group 17. So double check K and N. K 2, 4, and then this one is 2, 8, 7, so it will be K and N. Okay, so it's C. Yeah. So if you have any question, you can ask. Now next, phosphoric acid. Phosphoric acid molecules. So if you notice it will be H3PO4. Okay. So you can count H3, 1, 2, 3, PO4. Yeah. So now we can see what is the question. How many electrons are involved in the formation of covalent bonds in the phosphoric acid? Okay, this one interesting. Okay, covalent bond class. Okay, so how do we recognize that? Okay, so let's see. This one is a rare question. And why we try. Okay, so how many electrons involved? Okay, so if you see here, if one line means what? Single covalent bond. Meaning that it has, if one line here will be 2 electrons. Is that okay? 2 electrons are shared. So meaning that, let's see how many lines. 1, then now we count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 bonds. Right? If 8 bonds, how many electrons? One single covalent bond is 2 electrons, so 8 times 2, so it's 16. Okay, 16 electrons all together. They share the electrons. Okay, now which one is the covalent compounds? Covalent compounds, no metal. If you see the metal out already, magnesium metal, lithium metal. Okay, so 1 and 2 out. 1 and 2, 1 out, 2 out, so left 3 and 4. Okay, carbon and chlorine and hydrogen. Okay, so B. Okay, next is the hydrogen bond. Okay, so formation of water. So where is the hydrogen bond? Okay, so it's the here hydrogen bond. It's between the hydrogen with the electron negative atoms, right? F, O, and these 3. Okay, form. So here and here. Okay, so the hydrogen bond is here. Okay, so what is the bond? So it's a hydrogen bond. Okay, very straightforward. Okay, next, which of the following is the advantage of hydrogen bonds? Okay, so between the molecules. Okay, so class, let's say this kind of question, right? Maybe some statements are correct also, but the question asks you to choose the best answer. Sometimes the answer is not wrong, but you need to choose the best one. Okay, now ethanol exists as a volatile liquid. Okay, volatile liquid. If you see the PM version is mudah meluap, volatile means it change to gas easily. Change to gas easily. Okay, is it because of the advantage of the hydrogen bonds? If hydrogen bonds is very not very strong, is considered strong also. Okay, so is one of the advantage? No, it's not because of the advantage. Volatile liquid because of the low melting point actually. Not melting point, low boiling point. Okay, low boiling point, so that it will change to gas easily. Yeah. Okay, then ethanol dissolved in organic solvent. Is dissolved, but it's not because of the hydrogen bond. Ethanol could conduct electricity. No, not because of the hydrogen bond. Yes, it makes the ethanol soluble in water. Ethanol should actually is the covalent compound, right? If covalent, it should soluble in organic solvent only, right? Okay. B. But because of the hydrogen bond, then this ethanol, it can soluble also in water because of the hydrogen bond actually. It make it like this. It forms a hydrogen bond so that it looks like it can soluble. We say it is miscible with water, so it can dissolve in water or soluble in water because of the hydrogen bond. Okay, so this is the advantage. Okay, now next question. Okay, which of the following can form a hydrogen bond? So hydrogen bond, you go to search for what? F or N. See whether you have fluorine. Yeah, got here, right? Okay. O, no more. M, no. So only B. Okay. Okay, next, true about hydrogen bonds. Okay. This one is the application, right? I also asked in the quiz today. The wet papers stick together when wet becomes because of the hydrogen bonds form. Yeah, this is the application. Okay, next, hydrogen bond will form between the hydrogen chloride molecules, not hydrogen chloride with hydrogen chloride. Okay. Ethane has higher boiling point than ethanol because ethane able to form the hydrogen bonds. Actually, it's reverse. Okay, ethanol, it will form hydrogen bond actually. And then the hydrogen bond form between the hydrogen atom bonded with an atom of higher electronegativity, such as until here, the statement is correct, but bromine is not high electronegativity, like fluorine actually. F. And then O or N, these three. So the answer is A. Okay. If you have any question, you can ask. Now next, which of the following substance can form hydrogen bonds among its molecule? Again, you go to C, F or N. Cl no, CH no, Br no, so only N here for B. Okay, see here again, F. This is a hydrogen bond, so hydrogen bond. Okay, very fast one. Okay, so which one involves the formation of hydrogen bond? Okay, class, which one? The hair, right? Okay, easier to comb, not stick together. This one. Okay, now stick together 2 and 3 hydrogen bond. Okay. This one you can refer to the application of hydrogen bonds in your notes. Okay. Anybody can tell us where is which page? You can record down. Muka surat berapa? Anyone? Page 84. Okay. Correct or not, class? The application. Okay. The details you can read in details. The details. How they can apply it. Okay. Thank you, Beatrice. Okay, next below, one of the application of the chemical bond. Okay, the wet paper would stick to each other. Class, what is this? What is this bond? Keep repeating the concept, right? Okay, with a which of the following explain the situation above? Cellulose molecule in the paper form a bond. Okay, this one we should emphasize is a hydrogen bond actually. Oh, hydrogen bond. Okay, next, the lone pair share, no. Free moving electrons, no. Delocalizer, delocalize is for metal. Cellulose in paper absorb water when wet, cause the molecular size of protein increase, no. So it's the A. Okay, but here actually is form a bond. What bond is that? It's a hydrogen bond actually. Okay, is that okay? Am I too fast, class? Okay. Some types of compounds. Okay. Next, which compounds soluble in water? Okay. So class, if you see like this, all are non-metal, right? Non-metal, they are covalent compound. Correct? All are covalent compounds. Okay. But if they can form a hydrogen bond, okay, with water, then it can mixable with water, miscible in water, meaning that it becomes soluble. Okay, so which one can form a hydrogen bond, class? We search for the hydrogen bond. Which one, class? What do you think? This one? Anyone you have idea? Mana satu?
Is it 3 and 4?
3 and 4. Why? Why, class? Why 3 and 4? Can soluble in water. Let me see. Okay, if this one confirm cannot, okay, hydroxyl alcohol, right? Then it will form hydrogen bond. So 4 is confirmed. So 4 means A and B is out. Sorry, A and C out. Now we have 1 and 4 or 3 and 4. Okay, so 1 or 3. This one. Okay, what do you think? This one is what? Let me see. CH3NH2. CH3NH2. Okay. CH3NH2. Okay, it's the methyl amine or amine. Methyl amine. Okay, in Form 5 we are going to learn the naming. Okay, but it is not that popular also. Okay, so we go to search for the oxygen under oxygen. Okay, so this one. So the answer is A and 1 and 4. 1 and 4. Okay. Okay. Okay, next, dative bonds. Okay, what is mean by dative bond or coordinate bond, class? Coordinate bond means you can see this hydrogen it has no oxygen, nothing, because it already given to others already, so it has empty, no electrons. So that's why it has positive 1, right? Release the electrons already. So how? When it combine with this, the 2 electrons are totally shaped or contribute by the water here. Okay, so meaning that these two these two is only contribute by the oxygen from the water. So it will forms a dative bond. This is the dative bond actually. This part. So here, dative bond. So class, I already mentioned in the class, they will use only 2 examples of dative bond. One is what? One is this one. What is this called? Anyone know? What is this structure called? H. How many H? 3, right? And O. Positive. What is this called, class? Hello? No one knows? What is this?
Trihydrogen.
Trihydrogen oxide. It has another one. Another one. Another one. One single word one. Okay, hydroxonium. Yes, hydroxonium ion. Okay, which is the? It can be simplified by hydrogen ion actually in the acid. Hydroxonium ions. Okay, another one. I think later we'll see. Because not many dative bond we can ask. So which of the following?
Is it Na4Cl, ammonium chloride?
Ammonium only. Another one is ammonium ions. When you combine with chloride, then you form the ammonium chloride. But if if for the dative bond is this ammonium ions. This one is another one example, ammonium. Okay, so only 2 for the dative bond they will ask normally in the experience. Okay, so let's see. Most accurate, define the chemical bonds. Okay, so the bond form is a covalent bond which the shared electrons pair come from only one atom. Yes, this is the best definition. It's under covalent bond also because they share the electrons. Okay. Normally covalent bond is the contribution of the electrons are equally. Okay. But the coordinate one or dative bond, it will be come from one atom. Okay. Another one is this. Okay. This is what? These 2 electrons is contributed by the nitrogen itself. So this is the one, dative bond. This is the ammonium ion. Okay. So only 2 MH4 positive. Okay, next ammonia. Okay, formation of ammonia, boron trifluoride. Okay, ammonia react with boron trifluoride. Okay, so what is the so this one is extra one. Normally in exam they will use this one and this one. Okay, so this one is extra for you. Okay, so let's see here. If you see this one, it is contribute by the nitrogen here. Okay, so you forms it. So this is a dative bond also. Oh, active bond. Any more? Okay. You see, not many questions can be asked, right? For the active bond. Okay, next, I think last one already, no? The type of bond, the metallic bond, no? Metallic bond. Spelling, metallic double L. If you write one L only, it's wrong, huh? Okay, so property of metal can be explained in terms of metallic structure and bonding. What is the basis of metallic bond? So these are the concept now. Okay, the attraction between the positive metal ions and the sea of electron. Yes, this is a basis. Okay, sea of electrons. Remember? Okay, later we will see other questions also. Table shows electron arrangement for metal, 2A. So R, 8 valence electrons, so it belongs to group 18. So never react, never react. So it's noble gases. Already achieved octet electron arrangement. Now group 2, the group 14, this one give group 16. Okay, so which one will form the metallic bond? So search for metals, right? So metals, only one, right? So it's S metal. Group 1, group 2, group 13, they are metal. Yes. Okay, now this one is what? Sea of electrons. Sea of electrons. So electrons can move freely. Okay, move freely. No specific direction. You can just move like that. Okay, so gerak secara bebas. Okay, so this one is called sea of electrons. That's why the metal can conduct electricity because of the movement of electrons. So which one is true? Okay, exists as a gas at room condition? No. Metal in the room condition, it will be in the solid. Okay, high melting point? Yes. That's why it exists as solid. Soluble in water? No. Oh, no. Conduct electricity in solid state? Yes. Metal must, right? Metal can conduct electricity. That's why you see the wire for electricity, we use the copper, right? Copper is a metal. Okay. If iron also can conduct electricity. Okay. This one also the same. Sea of electrons, positively charged metal ions. So the electrons move freely. Bergerak secara bebas. Okay. So which one is correct? Sharing, no. Sharing of electrons between some metals. So this one should be covalent. Right. Transfer of electrons between non-metal and metal. This one should be ionic. Metallic force, positively charged metal ions and the valence electron are no. Okay. So here should be electrostatic attraction force between the sea of electrons and the positively charged metal ion.
Teacher, is it metallic bond can conduct electricity in any state?
In any state, the most will be solid, can, and then you heat it until molten. You can also. Class, I ask you if metal, some metals like reactive, it can dissolve in water, but seldom. No aqueous state. Gas? Cannot. Seldom the solid, the metal can change
Teacher.
to gas, right?
Is mercury metal?
Yeah. It's considered the molten state already.
Oh,
Not the aqueous state. It's a molten state. In the liquid form. Mercury, yes, it can conduct electricity. Okay. So in other words, normally you will see in solid and molten state, it can conduct electricity. The ionic, the difference between the ionic compound, this one is the metal. Solid can conduct electricity, molten state also can. Ionic, solid cannot but molten can. Okay. Why solid cannot? Because ions cannot move. Cannot move freely. Okay. In molten state, ions can move freely. Okay. Then for the metal, we are not going to use the ions. We use the sea of electrons. Okay, to explain the electrical conductivity. Yeah. Okay, next. Which of the following is matched correctly? Glycerol, covalent. Okay, let's see. Chloropicrin. Okay, so this one. Not ionic, should be covalent also, because of non-metal. Sodium chloride, sodium metal, non-metal, so this one should be ionic. This one paracetamol, what do you think? Ionic, correct or not? Is it ionic for paracetamol? Plus, no. This one should be covalent. Okay, so this one covalent, yes. So A. Okay, very easy to recognize. If metal, non-metal, then it will be ionic. Or non-metal, then it will be covalent. Okay. Now comparison. Comparison. In exam, I think very popular. Huh? Okay, here solution. Solution. How to form the solution class? Okay, the compound A put into water. Okay. Okay, then you soluble in water. Okay, then you see, okay, diagram observation electrical conductivity of compound A. So normally, if like this, under here, we are focusing to ionic or covalent. Or covalent. We seldom for this electrochemistry, okay, like this, electrical conductivity, we are going to look at these two only. We are not going to use the metallic, no, so only look at here. So you see here, this one in the solution, so it can or cannot conduct electricity. Yes, it can, right? So the bulb is lights out, right? Okay. So, which one forms shows the information? Okay. So here, if can conduct electricity in the solution, okay, aqueous solution, meaning that it must be ionic. So ionic, remember, it must be metal plus non-metal. Okay. Remember this. So we need to search for it. Okay. Group 14, non-metal. Group 2, group 17, group 18. Okay, group 18 not possible, alright. Group 18, so octet electron arrangement already. Right? Octet electron arrangement. So they never react. Okay, now group 17 are possible. Group 2 possible. Group 14 normally is for the sharing electrons. Normally. So be L and M, they will form the compound, ionic compound. Okay, so L and M. Okay. Which of the following pair of physical properties is correct about magnesium chloride? Okay, so magnesium metal. Metal, non-metal. So it's ionic, right? Ionic compound. So ionic compound soluble in water? Yes or no? Yes, right. Larut, soluble. Ionic, soluble in water. But insoluble in organic solvent, so these two out already. Then can conduct electricity in molten state? Yes or no? Can, right? Can. No. This one not conducting, wrong. Okay, why? Why can conduct electricity, class? I hope you remember, You remember the reason why can conduct electricity? The three words. It has freely moving what?
Ion.
Electrons? Ion. Yes. Not electrons, freely moving ions. Okay, for ionic, I hope I talked so many times already. You can remember. Okay, model of atoms. Okay, now CH4. Okay, CH4. That's what is this? Ionic or covalent?
Covalent. Covalent compound.
Covalent, because metal, non-metal with non-metal. So which one is the property? Okay, so covalent,
B.
so dissolve in organic solvent. Okay, covalent should be low, low. Able to conduct electricity in molten state? No, not able. Why? Because it has what? No freely moving ion, or it consists of molecules. Okay, again, exam question, CH4. Okay. Dissolving water? No. Dissolving organic solvent? Yes. Should be low.
Teacher,
Hmm.
covalent compounds cannot dissolve in water.
Yeah, cannot. It is soluble in organic solvent. Right?
So paracetamol is not soluble in water.
Yeah, if they can form the hydrogen bonds, then it can be visible.
Some
There are
only.
some only, but majority is insoluble.
Okay. Okay.
Okay, able to conduct electricity in molten state. Not able. Okay, now this one joined with periodic table, right? Okay, so diagram shows the periodic table. Okay, so X, Y, and Z. Okay, so let's see. 1, 2, 13, 14, 15, 16, 17, 18. Correct. So this one group 14. Group 14. This one group 17. This one group 1. This one group 2. Okay, so now following are characteristics for substance 1 and substance 2, which form between the X, Y, Z. Okay, so class X and Z, it forms what? X and
Ionic compound.
ionic. Okay, the formula, yeah, is exact, correct? Let's say Y and Z. If Y and Z,
Covalent.
covalent. What is the formula, class? If Y and Z, they form Y and Z. Is it YZ? No, right?
Why
Anyone
is
know?
that 3? Why is it 4?
YZ 3 or YZ 4? 3 or 4?
Why is that 4?
Should be 4. YZ 4. And why 4? Because here 14, right? You still need 4 more electrons to be shared. So this one only. So meaning that you need 4 Z atoms. Contribute 1 electron each. Okay? To be shared with Y electrons. 1 Y atoms. So YZ 4. So it's covalent. Okay? Then which one is correct? Substance 1 and 2. So 1 can conduct electricity in molten state or aqueous state. This one, if you see this, what is this? Ionic or covalent class?
Ionic.
Ionic. Okay. High melting and boiling point, soluble in water. So all are ionic. Number 2, so meaning say ionic, it will be SZ. Okay. This one will be YZ4. Confirm, cannot conduct electricity in any state. Okay. Low boiling point, insoluble in water or soluble in organic solvent. Okay. So 1 and second. YZ2 4. Sometimes you see in the exam will be 3 options on here. Means each one will be 33.33%. Correct? E4 will be 25%. So, okay, higher chance to get correct. Well, still a lot of questions. Never mind. Okay. After we discuss this, then we go to the structure or essay. Okay, diagram shows the arrangement of STUV. They are not the interest symbol. Okay, now let's list out electron arrangement. S 4, right? This one is 2 6. This one is 2 8 1. V atom is 2 8 7. Okay. Now, which pair elements from the compound that is spark lights up when in the molten state? Okay, so if spark can light up in molten state, what is this? What is this?
Ionic.
Ionic. Okay, if ionic, so which one can form ionic? These two? Or these two? Right?
UV.
UV or TU also can. UT also can. Right? UT. No UT. UV can. Okay, UV. Correct? Okay. If UV, what is the formula? 287. 1 electrons goes to 7. So become UV. Oh. Yeah. Okay, if UT, what is the formula, class? If U and T. This one lost 1, right? But this one needs 2. How? T atom needs 2 more electrons. But U only can contribute 1 or can release 1 electrons.
U4. U4T.
U4T. Okay, let's see. U4T. U4T. Meaning that this one lost 4 electrons. If this case, each one lost 1, right? Then T only needs 2, but correct? Yeah, Jimmy? What do you think?
UT4. UT4.
UT4, okay, right? Which we change UT4. Meaning that U lost 1, T needs 2, but if 4 means how many electrons you need? Each one, each,
four use electrons.
but here if you write like this, if UT4 means this one you just have 1. Release 1, but you need, there are 4 T atoms needs the 1 electron. So definitely this one is wrong. Okay, any other answer? How about the others? No, now we are talking about the ionic. So if this one is group 14 already, S will be 14, so there forms the covalent already. Okay, so ionic U and T is possible because this one metal, this one non-metal. T atoms non-metal, this one metal. So they can form the ionic. So my question now is, what is the formula? Okay, Lucas, you get what I mean? Okay, how about the others? If U and T, how is the formula formed? UT2. UT2. Okay. UT2. Okay, very close already. Meaning that, you see, if U1, meaning that you lost 1 valence electron, so it becomes, then there is 1 electron. Then it goes to it received by the T. But if UT2 meaning that you need 1 T atoms needs 2 electrons, right? Here only 1, so not enough. Even worse, here T2 meaning that you need another 4, right? TU2. Okay, TU2. TU2 concept is correct already, huh? But normally we will write the metal first, huh? So it should be what? Should be U2T. Okay, then if you write TU2, actually it's wrong, huh? Norman? But your concept is correct already. So it should be U2T. Okay, let's draw out that. Let's say here, T, T is 26, right? T26. T 2 okay, 26. Right? 26. How to achieve octet? You need to gain 2, right? If we U only, 1 U, 281, right? Is 281. So TU 2 8. Okay. If here there is one valence electron is donated, right? Release. Then you gain by the electron, gain by the T, right? So meaning that this one becomes positive, right? This one is okay already, it's 28, it's octet electron arrangement. But this one is only 27, right? 27 only. Not yet becomes octet electron arrangement, correct? So how? So you need to receive another electrons from another U. Okay, class. So meaning that you need to have another U give another 1 electron. Okay? So positive. So this one is 2, 8 also. Then here, no more 2, 7, actually 2, 8 already. So the charge is 2, negative. Okay? So the formula should be U2T. Okay, U2T. Matter we will write first, huh? Okay, matter tulis dulu. Baru matter. Or positive ion first, then negative ions. Okay, now class. Okay, now. Okay, so rest for 3 minutes. I got to drink water first. Yeah. Then we'll go to structure for essay. Yeah? Okay. Okay, here will be page. We discuss until this one, Kelantan. Okay, muka surat berapa? Which page? For structure. Okay, kita rehat sekejap. Tunggu Okay, class. Now we continue. Okay, diagram shows the formation of the metallic bond. Metallic bonds. Okay, so valence electrons you see here. Because the metal, right? Metal, like if group one valence electron is group two valence electron, right? So the electrons is released, right? Okay. So the positively charged metal ions, then the electrons it can move freely. No? Oh, okay. It forms a sea of electrons. Okay, it's delocalized of electrons. Okay, so what is the name for this process? Y? Class? What is the name? Okay. Delocalize, delocalize of electrons. Yeah, certain part. This one is under. Okay. Delocalize of electrons. Okay. Then what is represented by Z? Z. Okay. Lautan electron, sea of electrons. Okay, next. Table shows the result of electrical conductivity. Okay, for P, Q, and R. Okay, this one, everybody you should know how to analyze this. Okay, electrical conductivity in solid. If can conduct electricity, P, meaning say what is P?
Ionic compound.
Metallic.
Not ionic, it's metallic.
Oh, sorry.
Yeah, so it should be metallic. Okay, good. If it's solid, if you see solid can conduct electricity, confirm is metallic. Okay. Then in molten, metallic confirm cannot. Then but here another one, Q, it can conduct electricity, but solid cannot. So one can, one cannot. So this is what Q is what
Ionic.
ionic. Okay. Then both cannot. Means all state. So this one is what covalent. Okay. So the only concept is here already. Okay. So what is suggest P, Q, and R? Okay. So here, do we give name or not? Okay. So suggest the name. So magnesium or any metal. Okay, any metal. Okay. Q, ionic compound. Sodium.
Yeah. How about aluminium?
Yeah, okay. Metal. You mean P, huh?
Yes.
Okay. Any metal.
Okay.
Like calcium, magnesium, zinc, copper, all these can. Oh. Okay, next R are covalent compounds. Covalent compounds, for example, naphthalene or naphthalene. Okay, and then one more here. When you suggest, right, you don't suggest the gas one. Do you get what I mean? Because here, it here put is the solid now, so you cannot choose something that is in the liquid form or gas form. Okay, let's say R, you just suggest carbon dioxide, right? Cannot, no? Okay, why? Because carbon dioxide not possible in the solid state. But solid state carbon dioxide can, because dry ice actually made from the carbon dioxide. Actually. But others like what? Like hydrogen gas, for example, cannot. So choose something that is suitable for the question. Okay, so naphthalene, spelling must be correct. You can write in BM1, sodium chloride. Okay, this is naphthalene. In BM is naphthalene. Naphthalene. Okay, next. Okay. Substance P are widely used in the wiring system in home. Oh, P. Meaning that here we cannot choose the magnesium, right? Okay. If wiring, okay. What is the metal used, class? Test your common sense.
Copper.
Copper. Yes. So this one P you should put copper. Okay. So remember for wiring is a copper metal. Copper. Okay. Explain how the substance P can conduct electricity in the solid state. In other words, so this one actually just explain the formation of the metallic bond. Actually, you need to mention delocalized electron. Okay. Yeah. So, any more question here? Yeah. Okay. So here. So atom P release electrons, valence electrons to form a sea of electrons. Okay. Do I need to translate for you? Your English should be very good, right? Then to form the freely moving electrons, or okay, forms a delocalizer. Okay, then we go to your notes. Okay, begin nota. Okay, chapter 5. Okay, and the metallic bond here. Okay. Okay, so you can use the explanation here. Okay, atom P lost the valence electrons, become positively charged ions. Okay, ions. Then valence electrons from the metallic atoms free to move throughout the structure. Okay, and then this is called delocalized electrons. Okay, then it can conduct electricity. This is page 86. Okay, page 86. Okay, semua boleh salin dari sana. You can copy from there. Okay. So you can conduct electricity from the negative to positive terminals. Okay. You can use the one in the notes there. Yeah. Page 86. Okay, next we look into the next question. PQRS proton number 17. So it's 2x7. Every time you look at this kind of question, write out the electron arrangement. This one is 2x2. This one is 2,6. This one is 2,1. Okay. So it forms if under metallic bond, metallic bond will be this one and this one. But if ionic will be this one also can, this one also can, this one also can. Okay. So define metallic bond. Metallic bond, how to define, class? Okay. Electrostatic force of attraction between the positively charged metal ions and the sea of electrons, or delocalized valence electrons. Okay, so it's an electrostatic force of attraction between positively charged metal ions and the sea of electrons. Okay, this one you can find. Next, among PKIs, which one can form a metallic bond? Okay, so which one? Go to find the metal. Q and S, right? Q and S. Yeah, Q or S. Anyone, anyone. Okay, next, explain how the magnetic bond form to mention, okay, in here. Okay, so again, same explanation as this on page 86. Okay, so Q atom, okay, so here you see Q must mention atom, release two valence electrons. Remember, mention two because it has two valence electrons, right? To forms a Q2 positive, and X is delocalized to form C of electrons. Okay. If you mention the S atom must mention release one valence electron to form the S positive, and is delocalized to form the C of electron. These two are the same. Okay. Then point 2. So the electrostatic force of attraction between C of electrons and the positive charge ion. So this one depends to you use the, you want to mention about this Q2 or S positive. Choose one only, choose one only. Pilih satu saja to form the metallic bond. Because here you can choose Q or S, no? Depends to you which one you choose. Okay? So these two, for the metallic bond, you need to mention these 2 points. Okay. Next, slag line, which is used to treat the acidic soil, is an ionic compound that forms from the X and oxygen. Okay. Draw the electron arrangement for the slag line. Okay, X is 20, then O is 6. Okay, class. If X electron arrangement 20, electron arrangement is 2, 8, 8, 2, right? This one is 2, 4. Oh, 2, 4. 2, 8, 8, 2, 2, 4. Okay. So how to form the electron arrangement? Okay. I think got something wrong, Oxygen should be 8, otherwise you cannot, right? So this one make correction, here should be 8. So electron arrangement is 2, 6, ini baru betul. If 2, 4 is for carbon, okay? So how to forms? It's very simple, this one. This one 2, right? Okay, so 2 we release, becomes X2 positive, right? Lost the 2 electrons. 2 valence electrons is received by oxygen atom, so becomes 2, 8. So all 2 negative, 2 positive, 2 negative. Yeah, so it'll be like this. Okay, so at the end, this one is 2, 8, 8. This one is 2, 8. So 2 positive, 2 negative. Okay. Okay, class. If really you are not in time to draw all, later you can watch back the recording. Okay, next. The diagram shows the giant molecular structure of silicon dioxide and simple molecular structure for carbon dioxide. This one is giant. Giant. Giant bronze belly. Okay. Giant molecular structure, silicon dioxide, silicon 4 dioxide actually. Okay. Then this one is carbon dioxide, CO2. So this one is C actually. So it's not clear, C, this one O, this one O. So double covalent bond. Okay, now compare the melting point and boiling point of 2 structure. Then explain. Both are covalent, right? Okay, but this one is giant. This one is simple. One is simple, one is giant. So class, which one? Compare, meaning that you must have the comparison. If we want to compare, so which one has a higher? Which one? What do you think?
Giant.
Giant.
Giant one. Okay, why? Logic, right? Giant, this one should be higher melting and boiling point compared to the carbon dioxide, right? Okay. So if really you, let's say, during the exam, you forgot how to explain the giant one, then we go to explain the lower one, right? Simple one. Simple one is what? Covalent bond, right? Covalent, we learned already, it has lower melting point or boiling point. Okay, why? Why it has a lower boiling point, melting point?
Weak van der Waals force.
Okay, very good. It has weak van der Waals force. Okay, so little heat energy to overcome, right? To overcome it. So lower melting and boiling point. No? Okay, then how about this? Giant one. Higher, right? Higher melting point or boiling point. Okay. Now everybody you go to search. Okay, what is the bond or attraction force between the giant molecular structure? Okay, you go to search for your knots. Okay, muka surat berapa?
$89.
89, 89. Yeah, everybody you go to 89. Yes, yeah. Okay. So it has very high or higher melting or boiling point. Why? Because it has very strong carbon-carbon covalent bond. Okay. This one very strong one. So a lot of heat needed to break the strong carbon-carbon covalent bond. Okay. This one also the same. This one got weak one. Okay, weak van der Waals, small amount of energy. So heat energy. Okay. Okay, so this one you can write the higher. Okay, silicon dioxide has a higher melting point than carbon dioxide. Okay, comparison words. Okay, why? Because strong covalent bond. Okay, so a lot of heat energy. Okay, to break the strong covalent bond. Okay, then simple covalent bond, it has weak van der Waals force of attraction between molecules. So little heat energy required to overcome the force. Okay, you can refer to page 89. Okay, get from there. No need to copy exactly the same like this. Okay, you take out the keywords on it. Okay, next here. This one very similar to your exam, right? Okay. In the molten state, compound X and compound Y, yeah. So here already molten, So plus X, this one should be Y lah. Experiment 2, this one should be Y. So spelling wrong, so this one should be Y. Okay. Then this one shows the reading. So plus, what is X, compound X and compound Y plus? What is compound X? What is compound Y?
Compound X is covalent.
Covalent. Can you give example?
Hydrochloric acid.
hydrochloric acid not possible because HCl it has no not solid no HCl it either it is in gas form, okay, then when dissolved in water then it forms a hydrochloric acid already. So not possible becomes the molten state. You get what I mean? Arina?
Okay. So it is either gas or solid.
You mean which one?
Hydrochloric acid.
No, it's either gas or aqueous solution.
Oh, okay.
Okay. For example, you can change it to covalent one. Then we have done in the lab. Naphthalene. Yeah, correct. Naphthalene. Easiest. Okay, naphthalene. Yes. Okay. Then this one. Ionic, all right. So ionic, what example we use? Means what? Lead 2 chloride, lead 2 chloride. Okay, so we heat until it's melted. So it becomes a molten. Okay. So type of compound for molten X. So is what? Covalent compound. Okay, covalent compound. Yeah. Don't write covalent bond, compound. Okay, now explain the difference. Observation. Here. In X, molten X. Okay. It shows this is what? Electrical conductivity. Can conduct electricity on it for molten compound X. Yeah, class can or not? Cannot, right? Zero. It shows no electrical conductivity. Cannot conduct electricity. Why? You need to explain. What is the reason? What is the reason, class?
Because naphthalene only contains molecule.
Okay, good. Yeah, send the answer. Oh, I hope all of you know how to answer this. This one consists of molecules only. Okay. Or you write no freely moving ions. Okay. Then X. Sorry, Y. It has what? Freely
moving ion.
Okay. I hope all of you remember this now. Okay. Emitter, neither not deflect now. Okay, so cannot conduct electricity. This one can conduct electricity. Okay, it's a covalent ionic. Then this one contains molecules only or no freely moving ions. So this one contains freely moving ions. Okay, no need to build a table actually. Yeah, you can write in sentence. Do the comparison. Okay, B. Okay, this one is what? The pen. Okay. Suraj hand was smeared with pens while helping his father pen the house. Okay. So trying to wash his hand with water. Okay, but cannot to remove the pen. Explain why water cannot remove the pen. And on the Suraj hands, suggest one substance that can replace water to remove the pen. Okay. So class, pens, what is the content? Is ionic or covalent, class?
Covalent.
Covalent. Okay. So here, why cannot use the water to wash? Water cannot, right? Cannot. Why? Any idea? This one related to the property. Okay. Why?
Cannot dissolve in water.
Yeah, very simple concept. Cannot dissolve in the water. So, but we know that covalent compound it can dissolve in where? Organic solvent, correct? Organic solvent.
Yeah.
So any suggestion for the organic solvent that I asked you to remember? Example, right? So what are the example for organic solvent?
Propanol,
Propanol can lah. Propanol. What else?
alcohol,
Alcohol also can lah. But normally we don't use alcohol. Okay. So, okay, the pen contains the covalent compounds. Okay, not dissolved in water. So, example, dissolved in. We use the turpentine. Okay, turpentine. The solvent for the pen actually. Propanol actually also can. Can. Turpentine. Okay. Now here, next, last question I think for tonight. Okay, a type of covalent bond where the electrons pair that is shared come from one atom only. So what is this bond?
dative,
Dative bond? Dative bond or coordinate bond? Okay, based on the statement, state the type of bond. Very simple now. Okay, so it's dative bond. Okay, dative bond. Okay, so